Now let's just move on further towards the question number 4, which says calculate the area of the designed region. So let us suppose if I'm just taking this particular figure over here, this is actually the designed region, this is actually the region that I have taken over here. So I have formed this figure all by myself. So you consider this situation first of all. It says calculate the area of the designed region. So this is my designed region that I have to calculate, which is actually the figure common between the two quadrants of a circle of the radius 8 centimeter each. Now we have to find out the area of this particular designed region. So let's just calculate it. First of all, as you can see over here, if I am just starting with taking it as ABCD, let us suppose if I'm just taking it as A, B, C, I'm taking this as C, I'm taking this as D, I'm taking this particular point as nothing but E, and I'm taking this particular point as nothing but F. And let us suppose if I'll join these 2 points over here. So I am actually taking this particular figure just same as that of it, but I am removing a design so that I can able to find the whole solution set in an easier manner. So let us suppose if I am joining this A and C together. So let us suppose if I am joining this A and C together in such a manner. So as you can see, if I have joined this A and C, and first of all I am about to find out the area of the section, which is nothing but this A, B, C, P. Sorry, I have taken it as F. So A, B, C, F. First of all, I'm finding out the area of this particular section, and then again I will find out the area of this particular section, this particular section that we have. So if we'll subtract the whole particular square with these two sections, then I will definitely be able to find out the area of this particular shaded region. Now let's just start with finding out the area of this particular square. So let us suppose if I'm just starting with finding out the area of this particular square. So the answer, let's just start the answer. Since we know that AB is nothing but is equal to BC, which is nothing but is equal to CD, which is nothing but is equal to AD, and all of them are actually nothing but 8 centimeter. So the area of the square should be nothing but is equal to, this is our square. As you can see, this is nothing but our square, which is nothing but is equal to area of the square we have is nothing but is equal to, this is nothing but is equal to, we have 8. So this is nothing but 8 square, which is nothing but is equal to 64. Now let us suppose if I am just calculating the area of this particular quadrant first, and then I will find the area of this particular triangle. So let us suppose if I'm just moving it aside, because right now I just do not require this area of the square. Now let us suppose if I'm just taking the area of this particular triangle, that is nothing but the triangle ABC. So the area of the triangle ABC actually nothing but is equal to half into base into height. The base I'm taking it as AB and the height I'm taking it as BC. So this would be nothing but a half into 8 into 8, that is 64. So this is half into 64, which is nothing but 32. So as you can see, this area is nothing but coming out to be 32 we have centimeters. So this is 32 centimeter square, which is nothing but the area of the triangle ABC. Now let's just calculate the area of the quadrant we have, which is nothing but AECB. Now let's just calculate the area of the quadrant. So let us suppose if I'm just starting with finding out the area of the quadrant, which is nothing but we have A, B, C, E. So this would be nothing but is equal to pi r square divided by 4. Hence I am taking the value of pi as 22 by 7. So 22 by 7 into radius. Since you can see all by yourself that the radius of this particular quadrant is nothing but 8 itself. So this is 8 square divided by 4. So hence at the end we are getting 2 and 1 and 1. 2 into 2 is nothing but 4. So further we have 64 divided by 7 into 2. So this is nothing but 2. We have 64, we have 11. So this would be nothing but 2 into 3 and 2. So we have 32 into 11 divided by 7. This would be 352 divided by 7. We have the centimeter square. We have this as nothing but the centimeter square. Now this is nothing but the area. This is nothing but the area of the quadrant. This is nothing but the area of the quadrant, which is ABCE. Now in the similar manner, if I'm just talking about this particular shaded region. Now let's just count this shaded region only. If I'm just talking about the area of this shaded region, then how we can able to find it? If I will subtract the area of this triangle, from the area of this quadrant, you can see all by yourself. If I will subtract the area of this particular quadrant with this area of triangle, then the only section that would be leave is nothing but this section. The only section that would leave is nothing but this section. This is the only section that would be left out if I'll subtract these two areas. So let us suppose if I'm subtracting these two areas, so the area of the half shaded portion would be nothing but is equal to the area of the quadrant minus quadrant is ABCE minus the area of the triangle ABC. So this would be nothing but is equal to 352 by 7 minus of 32. Now let's just take the LCM over here. So this would be nothing but 352 minus of 14 and 21. This would be 22 divided by 7. So we are getting 352 minus 224 divided by 7. Now let's just sort it out. If I will sort it out, so this would be nothing but 352 by 7 minus of 32. So we have 352, we have 224. This would be nothing but 8. We will get the 4 over here. This would be nothing but 2, and this would be 1. So this is 128 by 7 centimeter square. This is nothing but the area of the half shaded portion, and we know that these two are actually symmetrical to each other. So if this is 128, then this is also 128. So in the similar manner, similarly, we can able to find out the area of the other half shaded portion, and this would be nothing but is equal to this is a designed portion, we can say, or a shaded portion. So let us suppose if I'm instead of shaded, I'm talking about the designed portion. So this is again a designed portion to me. So the area of the designed portion would be again 128 by 7 centimeter square. Now let's just talk about the total area of the designed region, portion is nothing but is equal to the twice of 128 by 7, and this is nothing but a 256 by 7 centimeter square, and hence this is nothing but the answer for this particular question, that the area of this particular designed portion that we have is nothing but is equal to 256 by 7 centimeter square. And in order to find out this particular answer, we do not need the area of the square at all, because we just have calculated the two areas, that the area of the quadrant and the area of the triangle, and using that particular thing we have calculated the area of this designed region. So this is all about the solution set for the question number 4.